Hi everybody, it's Leanne here. I'm going to go over the problems for section 4. For section 4 you needed to do 3, 6, 7, 8, and 9. And so let's get started. I'm going to read number 3 and then we'll get to it. Number 3 is the chocolate problem. So the dark chocolate is made with chocolate and cocoa butter, and it's in a ratio of 5 to 2, cocoa to cocoa butter. And so you had to solve this problem with thinking of C as the unspecified number of grams of cocoa, keeping in mind that 5 to 2 ratio, and then just reason about the quantities. And so here's what I did here. All right, so the brown strip diagram you can see is in the ratio of 5 to 2, and so the first one here represents the cocoa, and then the second one here represents the cocoa butter, and so it's in a ratio of 5 to 2. Since we're given an unspecified amount of C of cocoa and an unspecified amount then of cocoa butter, then we're going to think of each of these pieces as this whole C divided by 5. So all of these are C fifths. And the same goes with the cocoa butter. Since we don't know the actual value of the butter, we know that the whole thing then is half of the B. All right, so if we use the variable parts perspective and we think of one group here as being made of the C grams of cocoa, then the amount of cocoa butter needed is 2/5 of a group, because it has two parts, each being 1/5 of the whole. And so if we were to write some equations here, we would say that to figure out the amount of cocoa butter we need to find 2/5 of the amount of cocoa that we have. To figure out the amount of cocoa we need, if we have the butter, cocoa butter, we're going to take the cocoa butter divided by 2, and then we need 5 of those to get the amount of cocoa. All right, number 6. Number 6 is asking us to really think about paint colors. And again, it's excuse me, it's similar to the last problem. Peacock purple paint is made by mixing red and blue in the ratio of 3 to 7. And so we have this strip diagram in the ratio of 3 to 7. And just like in the chocolate problem, we have an unspecified amount of red and blue paint. And so what we're going to do is we're going to think about how we can reason through this. All right, so in the first part of this question, we're going to think of the red as one group. So the R liters of red as one group. And so if this is our one group, then the amount of blue that's needed is going to be 7/3 of a group. So to get the amount of blue, we're going to take our 7/3. You might want to think of it as 2 1/3. We need 2 1/3 of these. 7/3 times the amount of red that we have. So we need 2 1/3 of these, right, to figure out the amount of blue. In the second part, we're going to think about it sort of opposite, the other way. So this time we're going to think of the B liters of blue paint as one group. And so the amount of red needed is going to be 3/7, because it takes up 3, of course, of the 7, as you can see. So 3/7 of that blue. So our equation there would be R equals 3/7 times B. If you use the how many units in one group division, you can see that each part, so this is very much like the cocoa problem, each part can be represented by, like in this case, R, this is our red, R, divided by 3. So each of these parts is 1/3 red, 1/3 R, or R divided by 3, or you could write it traditionally R divided by 3. Ooh, sorry guys. You could also think of the B's the same way. You could think of each of those pieces in the B as B sevenths, or B divided by 7, or a 7th B. So each of these is a 7th of the B, since this whole thing is B, or blue paint. And since we made the strip diagram, it's a nice visual to see that since the ratio is 3 to 7, we know that all the parts are the same size. So we know that 1/3 red is going to be equal to a 7th blue. A third red is going to be equal to a 7th blue. All right, let's go to number 7. In number 7, we had to analyze some drawings. And this is the fertilizer problem. We had to analyze some drawings and some equations and decide if they are correct and explain why or why not. And so I'm going to go kind of back and forth here. So in 7a, the equation and the drawing are correct. And I'm going to read this and then we'll go back and look at it. That's because 4 equal groups with 9 parts in one group is the same as 9 equal groups with 4 parts in each group. And that should be a nice review of our definition of multiplication. And then, of course, all parts represent the same number of pounds. So if we go back to that, essentially what we have is we have this diagram sort of flipped on its side. And we can see that 4 groups of S is going to be the same as 9 groups of F in this diagram. Let's take a look at part B. Part B, the equation and math drawing are not correct. And that's because if we look closely, they're saying, this equation, that 9 groups of S, 9 of these S's, is equivalent to 4 of these F's, 4 groups of F. And that's not true. You can see that those are not equivalent in the drawing, in the strip diagram. So that's not accurate. And while I have this here, let's go ahead and talk about C. A 9th times S is equal to a 4th times F. That is correct, because what we're saying here is one of these is equal to one of these. And we know that that's correct. We're not talking about the whole thing, right? We're only talking about this little piece, because we know that this little piece right here is going to be named soil S ninths, or 1/9 S. And this little piece is going to be labeled fertilizer fourths, or 1/4 F. And so since we have a ratio here, we know that each of these pieces are going to have the same value. All right. Number 8. Number 8 is the draw a graph to represent the situation. So we have a ramp whose length and height are in the ratio 11 to 4. So for every 11 in length, we have 4 in height. So for every 11 we go over, we go up 4. Right? So I like to think about it and visualize it right when I read it. So we're going to think, first of all, we're going to sketch a graph, and then we're going to reason about the quantities in our math drawing and write some equations where C and K, are constants of proportionality, or in other words, our slope. So those are synonymous: constant of proportionality, slope, same thing. It's also, you can think of it as like the constant rate of increase. So explain how to interpret the constants of proportionality in your graph. So let's take a look at that lovely graph. So it said just to sketch one, so that's literally what I did. Make sure that you have your x-axis and your y-axis labeled. This is my length of ramp, and this is my height, and we know that for every 11 we go in length, we go up 4. And so I just simply sketch what that might look like. So if x is 1, then we know that y is 4/11ths of a group, or 4/11ths, because it's 4 parts where each part is 1/11th of a group. And so the C in this case is 4/11ths. And then if we think about this equation, y equals cx, that makes sense because our slope is going to be 4/11ths. If y is 1, then x is 11/4ths of a group, because it's 11 parts where each part is 1/4 of a group. So k is, in this case, 11/4ths, and y equals k, I think that's supposed to be x. Makes sense. All right, so the constants of proportionality, it depends on sort of which way you're looking at the graph. They're 11/4ths and 4/11ths, and those are simply the unit rates that correspond to the points 1, 4/11ths, and 11/4ths 1. And so both of those points fall on this line. So if I go over 1, I'm going to go up just 4/11ths. And if I go over, and so that's where this point comes in. And if I go over 11/4ths, I'm going to go up 1. All right, so that's what those points represent. Ooh, sorry, you guys. And so think of them as multipliers that relate the x and the y, and they tell us how steep the graph is going to be. So if we were to just look at what is the slope of the line, given that we know that the ratio is 11 to 4, we know that the slope of the line then is 4/11. All right, and number 9. Number 9 is another problem where we're looking at slope. Here we're considering the line that goes through 0, 0, and it also goes through the point 5, 7. And so we're going to look at this equation, y equals mx, where m is essentially our slope, you guys. And so that's what we're looking at, and we're going to talk about how we might interpret m as the slope of the line. So it's really just this problem, these two problems are really just about connecting what you already know about slope to this idea of proportional reasoning. And so we know that the slope is 7/5 x. And we know that because it tells us about this point right here, right? It says that we have this point 5, 7. And so what I did is I kind of unpacked it a little bit to better explain. I made a table, and I just am using x values 0 through 5, and then I'm filling in the corresponding y values. So for every 1 we go over on x, we go up 7/5. For every 2 we go over on x, we go up 14/5. These are all going to be points on that line. And then I also took those improper fractions and I wrote them as mixed numbers, maybe so that that constant of proportionality shows up a little bit nicer in your brain. So 1 2/5, 2 4/5, 4 1/5, 5 3/5, 7. Of course, the difference each time here is 1 2/5. So we know that that's our constant. That's our rate. That's our constant of proportionality, and that's our slope. All of these same things are synonymous. When we say slope, we're talking about constant of proportionality. So for every 1 we go over, we go up 1 2/5. Or in this case, we're going to write it as an improper fraction. For every 1 we go over on x, we go up 1 2/5. Over 1, up 1 2/5. Over 1, up 1 2/5. Over 1, up 1 2/5. Yeah. Okay, so I hope that helps everybody, and I hope you're doing well. Thanks for listening.